Hello, today we are doing Chapter 6, Section 4. Our essential question today is, what are some of the characteristics of exponential growth and exponential decay functions? So, I'm going to go ahead and give you a fun little formula here. And this is one that you probably want to go ahead and commit to memory because you use it a lot. I know we use it in Algebra 2, we use it in pre-calc. It's just a very popular formula. Y is going to be your final amount. Sometimes that's written in function notation, so it could be like A of t or something like that. A is your initial amount, what you're starting with. R is your rate, has to be in decimal. T is time, and what's in that parenthesis is your growth factor. Oh, got a little crazy with the arrow there. So let's go ahead and do a story problem. The inaugural, beginning first, attendance of an annual music festival is 150,000. And then it increases by 8% each year. We want to write an exponential function that represents the attendance after t years. And then for part B, we're going to evaluate that in the 5th year. So our initial amount, 150. R is 0.08. We're going to plug that into the formula. And there's our formula. 150,000 times 1.08 to the t. That really wasn't that bad. And then the value t equals 4 because that's the 5th year, and t equals 0 represents the 1st year, which I think is a little bit where they're trying to trick you on that. So we go ahead, plug everything in, and you get 204,073. It says round to the nearest 1,000, so 204,000. And again, if you were having trouble with why that t is 4, 1st year is 0, 2nd year, 3rd year, 4th year, 5th year. All right, here we've got a website that has 500,000 people. In 2010, the number Y of members increases by 15% each year. We want to write an exponential growth function that represents the website t years after 2010. And then they want us to evaluate it in 2016. Very similar to our last problem. Why don't you hit pause and see how you did? All right, this is a decay function. And if you notice, it looks almost exactly like our last formula, but instead of a plus sign, we've got a minus sign. Because it's decaying, it's getting less than, so we're taking away that rate of decay. So here we've got some tables. We want to determine whether each function represents exponential growth, decay, or neither. Remember, if it's exponential, you're going to be multiplying by the same amount each time. So for A, you're multiplying by 1/3, which is less than 1. So that is going to be a decay function. For B, you're multiplying by 2. It's going up. That is a growth function. All right, try those two on your own. Let's see how you do. Yeah, number 3, I think, is the tricky one. It's a neither. You're actually adding 7 each time, which I was going to make it actually linear. So on here, these look like they might be hard, but they're really easy. We want to rewrite each function to determine whether it represents exponential growth or exponential decay. Well, I look at the growth factor, it's 0.96. I should have dealt with that t over 4. Well, using our rules of exponents, remember that's a power of a power, so that's really 1/4 to the t. It is going to be a decay, though, because that is less than 1. B, it's a little bit more involved. I've got 1.1 t minus 3. Well, they're subtracting exponents. So remember, subtracting exponents is like dividing. So 1.1 to the third power, 1 divided by 1.1 to the third power is going to give you approximately 0.75. That is going to be a growth factor, though, because that number right there, that 1.1, is greater than 0. Or greater than 1, I'm sorry. Greater than 1. Why don't you take a second, try these 4 on your own, and let's see how you did. Hit pause. Four and 5 were the easy ones, because you can think of that as 1 minus 0.08. So your rate is 8%. Here, think of that as 1 plus 0.2. So your rate is 20%. Here, you have to think of that as 1.02 to the 10th plus 1.02 to the t. Again, you're going to be separating those out. I didn't mean to say plus there. It's a power of a power. You multiply it on the inside. Sorry about that one. So that's actually going to be 3. And then if you take and you're going to apply that okay? Should have had my calculator out on this one so I could show you. 1.02, raise that to the 10, and that's where that 1.22 comes from. It's actually 1.218. Sorry about that if I confused you. All right, take a second. Think about that, where you got stuck, what's puzzling you, or what you're feeling good about. Answer that to yourself. Enjoy.